nanotechnology. It's a buzzword. Not many people really understand what it's all about. But it's really about self-assembly. It's really chemistry of the 21st century. What do we mean by that? Well, could one day we create a computer by chemistry? That would be interesting. Well, it's already been done. Look at this. Without any knowledge, DNA has created a computer device, our brain. And we should be able to do that in the future. Well, let's look at one thing that we've tried. We've made some nickel cluster compounds, some MOFs, metal organic frameworks. And the idea was to create a two-dimensional framework. And what was behind it? Well, the old magnetic storage devices. How did they work? You passed half the current needed to magnetize one of the cores down one of those wires, and the other half at the same time, and then it was magnetized. Okay. Well, we've actually tried to start at the first rung on the ladder on making something like this, and if we can succeed, then we can go down by a factor of 10 to the 7th in one dimension, and in two dimensions it would be 10 to the 14. It's the first rung on a very long ladder, but it's really a start. This is a nickel organic framework made with my colleagues Prashant Jain, Naresh Dalal and Tony Cheetham. And in fact we've actually been able to produce some flat sheets, but not on a surface so far. Well, what is nanotechnology? Well, it's much more than just small things. It's molecules that do things. And of course life has created hemoglobin, which is a molecular machine. That's nanotechnology. Now, one thing some years ago that I was interested in was how do nanotubes form. If you look under the electron microscope, you see the walls of the nanotubes here. This is what happens under the electron microscope. You just see the cross sections. And sometimes you get these closed off ends. And I thought maybe what is happening is the metal core at the center of these nanotubes. If we look at it under the electron microscope, it will look something like this. Maybe a little igloo of carbon comes out due to what I call surface reconstruction. Okay? Well, if surface reconstructs on a carbide, metal carbide, perhaps you'll get a little layer of graphene. Okay? Like this. And that seems to be what happens. Florian Banhart, Mauricio and Umberto Torones have worked on this, and they've found that if you look under the electron microscope, look at this. This is the metal core here in the center, there. And if you look at this little line appears, and waves of nanotubes come out. And here, what we can see, if we watch this, we should see, whoops-a-daisy, let's look at this. This should be a time, oops, let's go. It's a little bit sensitive today. I don't know why it is. But here we can see the nanotube. And watch this. You're going to see in real time nanotubes being born. Okay? That's the birth of the nanotube. Now then, what do I think is the Holy Grail? The Holy Grail of nanotubes is the following. We have to have perfect control of construction. All the same diameter, all the same length. Now, if you consider some paper straws, okay? If we all the same diameter and stuck together with, say, a weak glue, hexagonal packing, then we'll actually have something that's intrinsically very strong. You can stand on it and it'll hold you up. Well, nanotubes already have that glue. It's called van der Waals forces. And in fact, what we really need is a bundle of 10 to the 15, 1,000 million tubes, all stuck together, maybe a meter long. This is all we've done so far, 20 double wall tubes in a bundle. And if we can do that, we'll have a material which is something like 50 times stronger than steel, and maybe 1/5 the weight. Now that's nanotechnology, and we're really not started. It's not just chemistry of small objects or clusters. It's not just that. It's absolute control of chemistry of large molecules which can do something. So 100 maybe times stronger than steel, 1/6 the weight. That's nanotechnology.